the day.
Yeah.
Good
Good
evening.
evening, sir.
Yeah, good evening. I hope everybody is doing well, and your exams, as sir told, have gone well in the school. Okay, எங்க ஸ்கூல்ல வந்து it is half yearly examination that is going on. So for grades 9 and 10, and it is terminal 2 examination for 12th. So we are ahead of the syllabus. நாங்க வந்து ஆல்மோஸ்ட் முடிக்க போறோம். இன்னொரே ஒரு சாப்டர் மட்டும் தான் இருக்கு 12th. So with that we'll come to an end of the syllabus, and then we will start board exam revision. Okay, so now we are on 12th standard now. We are looking at the chapter for current electricity. So அதுதான் நம்ம பார்த்துட்டு இருந்தோம். Last class I have started with the basics. Electric components நம்ம பார்த்தோம், and we have also looked at series and parallel combination of circuits. A combination of both series parallel வந்து what is how to evaluate the total current வந்து அதை எப்படி கண்டுபிடிக்கிறது. So that is what we have looked at so far. So இப்போ வந்து we will be moving on to a higher level concepts, அதாவது NEET and the JEE level questions வந்து நம்ம பார்க்க போறோம். So that is what is aimed for today. So some more questions நம்ம பார்க்கலாம். பார்த்துட்டு then I will we'll go to the higher level questions. So ஒரு bridge, it will be like a bridge course. Okay, fine. So I hope the screen is successfully shared and everybody is able to see it. And now I'll proceed with a question. Before question, we'll have a recap, and then we will look at questions. That would be much apt because once we recap, உங்களுக்கு கொஞ்சம் கிளியரா இருக்கும். In case you have any doubts, நீங்க தாராளமா கேட்கலாம். So I would want everybody to unmute and ask questions, because when we are looking at concepts like these, obviously it is logical and certain areas might be theoretical. So whenever you have some doubt or you feel somewhere you're stuck, never hesitate. Okay, it is very good to ask questions then and there. All right, so don't have a backlog. Okay, so we are here to help you out. So always grab the opportunity. Person who asks a lot of questions tends to learn more and grasp more. So yeah, so we'll look at the recap. Let's have a quick recap or a quick summary. Okay, so first formula for current. So current order formula let's look at immediately. So what is the formula for current? Anybody? How can you express current in terms of charge and time? We learned that.
Q by T, sir.
Yes, very good. I is equal to Q by T, wherein I is current in amperes, Q is charge in coulombs, and time is in seconds. All right. So this is one formula. And again, charge also has got one formula. This I have not discussed in the last class, but out of curiosity, I am asking. So how can charge be expressed in terms of multiples of electrons? Any idea? Q can be expressed in terms of multiples of electrons. We can write it as NE by T also. Okay, where N is nothing but the multiples, integral multiple, we say. It accepts only integral values, that is integers. All right, so N represents integral multiples. So, and E, what does E stands for? E stands for the charge of electrons. So electron charge is 1.6 times 10 raised to minus 19 coulombs. So while solving numericals, you can make use of this value. All right, so this is all about the first formula. Quickly moving on to the second one. The second one was, I suppose we learned what is Ohm's law, the concept of Ohm's law, which gives you the formula as V is equal to IR. Right, where V is potential difference, I is current in amperes, and R is resistance in ohms. All right, and the third formula was charge in terms of work done. So how can we write a charge and work done and potential? So the formula is V is equal to W upon Q, where V is again potential difference, W is work done, and Q is again charge. All right, so this is also a formula. By rearranging, you can write work done is equal to Q times V. Okay, this is also another formula that you can know just by rearrangement. This is the third formula. The fourth one is combination of resistors. So resistors in series combination, RS, can be represented as summation sigma I is equal to 1 to N Ri. Okay, where you just need to add the resistors. Whenever they are in series, that is one after the other, like this. This type of combination you call it series, and you just need to add each resistors, you know, algebraically, so you can get the total resistance. All right. So that's a series combination. But what about for parallel combination? You just need to take the reciprocal on both the sides for series. You arrive at parallel. That's the analogy. So 1 upon Rp is equal to sigma, I is equal to 1 to n, 1 upon Ri. All right. So you just add the reciprocals, you can find out what is the total resistance for parallel combination. And in parallel, how the resistors are connected? They're connected like this, one below the other, as you see. This is the type of connection. First one is R1, R2, so on, up to Rn. Okay, so that's the formula which also was discussed in the last session. And after that, combination of both series and parallel, that only, when you look at circuits, you can identify that. Okay, yeah, that was that. This is all that we had learned in the last class. So now we are going to move on with certain questions. Now, based on this recap, based on the summary, we will look at certain questions for the day. Okay. So here comes the first question. I'll just write it on the screen. So I'll give you a question. Let's go from easier ones to difficult ones. Okay. So first I'll give you an easier question. First question. The effective resistance of the combination given below is, okay, you'll have to calculate the effective resistance of this combination. So this is how the circuit is. So you have to find out what is Rxy, okay, the effective resistance at with respect to the point X and the point Y. Okay, so Rxy is what you will have to calculate. I'm giving you options. Option A, I'll first give you the values also. This is R1, R2. This is R2, you take it, and this is R3. Just change it. Okay, this is R3. All right. So these are the values. I've given them in terms of the variables. Okay. So you have to find out what is Rxy. Even before I give the options, I want one of you to try it to get the relation between the resistors. So you can try it and you can tell me. Okay. I'm going to give you the options, but I want you to try. You can just take a minute or two and tell me.
So that is the thing. Now carry on, madam. I have some other work. I just thought I would. Welcome, Sandeep. Sandeep, nice. Yeah.
So the options are, I'm giving you the options. First one, R1 plus R3 into R2 divided by R1 plus R2 plus R3. Option B,
I think so.
R1 plus R2 times R3 upon R1 plus R2 plus R3. Option C, R1 plus R2 plus R3 upon R1, R2 and R3. And option D, R1 plus R2 R3 upon R1 plus R2 plus R3. So which of the options you feel is right?
I feel like option B, sir.
Option B. Why do you say option B? How come?
Because R1 and R2 are parallel resistors. I mean, sorry, they are series resistors, so I think we could.
Very good. Yes. Okay. See, whenever you look at questions, now what method you have used is basically, the method of elimination. So you try to that is technically written like this. So R1 plus R2 is in parallel with R3. Okay. So whenever you have two resistors in parallel, for instance, if you say R1 is in parallel to R2, what would be the formula for R effective?
R1 plus 1 by R1 plus 1 by R2.
Exactly. So you take the LCM and you do the final reciprocaling, you get R1 upon R2, I mean R1 R2 upon R1 plus R2. Okay, when you take the reciprocal. Because you know that the formula is 1 by R effective is 1 by R1 plus 1 upon R2, isn't it? When you take the LCM, what do you get? You have R1 R2 and on the top you get R1 plus R2. Then you go for reciprocaling, isn't it? Because the value is 1 by R effective, but you want R effective. So what is R effective in turn? It's going to be R1 R2 upon R1 plus R2. I hope you guys are getting the logic, right? So this is how the formula came into existence. So here for this question, my R1 is nothing but R1 plus R2. So this entire term has to be considered as R1. Okay, and R2 term is R3. Okay, this is R2. So when you write the formula for this, so it's R1 times R2, where R1 is R1 plus R2 into R2. Okay, I'm using small R2. Okay, I mean R3 with your R2 is R3, you arrive at your answer. Okay, that is how you do it. Fine. Next question. Yeah, I hope I'm audible, right? So you can see that it is in series combination now, 2.5 and 5 ohms. So both of them in series, you just need to add them up, right? So when you add them up, 5 plus 2.5, 7.5, right? 7.5 and 4 would be in parallel, right? So what is the final answer? 4 parallel with 7.5, isn't it? So it's 4 into 7.5 times upon 4 plus 7.5, which is 11.5, right? Now you just need to simplify this, okay? 4 times 75 upon 115, because the 10 would get cancelled off, right? So you know how to simplify it further. So how much does this give you ultimately? 4 times 75 upon 115.
Sir,
Yeah.
sir, screen is not visible, sir.
The screen is being shared, no?
No,
It's not
sir.
shared? Okay, hang on. Let me reshare it. Yeah, you guys are able to see it now? Yeah.
Yes, sir.
Okay. Yeah. So, children, it might happen, sometimes find that because it's
Yes,
a
sir.
touch, laptop, by mistake, it might happen that the screen is being shared and the audio is being shared. So, what you need to do is you need to multiply the division and then go for addition. Okay. So, you just need to multiply and then go for addition. So, what is the final answer? Yeah. So, children, is it being shared now? The screen?
Yes, sir.
Yes, sir.
Yeah. Okay. And I just one more request. So in case because I'm using a touch laptop, a Chromebook, it might happen sometimes by mistake the mute. The mute gets enabled. Okay. The becomes mute. My mic, I'm saying. So if that is happening, I would recommend one of you to immediately put it on chat box that it is on mute so that I can hear the ping pong message and I can get back. Okay. Yeah. Please be vigilant. All right, so now going back, now you can see that 5 and 2.5 ohms resistors both are in series combination. Okay, so these both are in series. You just need to add them so that you get 7.5, and 7.5 and 4 would ultimately be in parallel. Okay, so that's what we are doing. So when they are in parallel, 4 times 7.5 upon R1 plus R2, which is 4 plus 7.5, which is 11.5. Okay, so you just need to multiply and then go for a division. So finally,
Sir,
what is the answer?
2.60.
2 point,
60, sir.
yeah, 2.60. Okay, so ultimately get 2.60 as the corresponding answer. So that's how we are going to decode this step by step. So one by, step by step, you need to reduce the circuit and then finally substitute the value. So that's how you arrive at the answer. So this is how combination of series and parallel circuits can be solved. Real time basis we have solved it. Okay, so that's how you do it, children. So now moving on. So we have looked at different varieties of questions for both series and parallel combination. There are again other varieties too. So we'll look at them too in the later stage. Now we'll move on to the next concept, finding out the total currents. Okay, and the readings of the ammeters and voltmeters. Okay, so we'll start with easier questions. So moving on. So now we're moving on to the third question for the day. The readings of, you'll have to find out the readings. Okay, so I'll just draw the circuit, the readings of the ammeters and voltmeters in the circuit given below are, so you'll have to calculate what are the readings of the ammeters and the voltmeters. I suppose you guys are familiar with what an ammeter is and what a voltmeter is, right? So when we looked at circuit components, I hope it was clear. So who can tell me what an ammeter is? What's the difference between the two? What are they? So what is the job of an ammeter? What does it do?
Measure the amperes, sir.
Yeah, it measures the current in amperes, right? So likewise, voltmeter is going to measure the potential difference. Ammeter is a device used to measure current in amperes, wherein voltmeter is an instrument which is used to measure the potential difference in a circuit in volts. Okay. So one important thing you will have to know is how to connect ammeters and voltmeters. How are they connected in circuits? Okay, there is a method to connect them. You cannot just connect them however you want. Okay, ammeters can always be connected only in series. You cannot connect ammeter in parallel. Okay, because you want to find out the current. So therefore, you will have to connect them in series only. Voltmeter, you will have to connect it in parallel but not in series, because you are trying to measure the potential difference across 2 points. That's the reason you connect it in parallel. Okay, so this is how the connections of ammeters and voltmeters are. So now I'll give you a circuit. So here comes a circuit. So this is a circuit. Okay, so these are the values that I've given you. You can see that the circuit consists of 3 resistors, 2 ohms, 24 ohms, and 6 ohms. You can find that 24 and 6 ohms are in parallel combination with each other, and there are 3 resistors which are in parallel combination with 2 ohms. Okay, so this is how as I already told you, same way. Yes, children. Am I audible?
Yes, sir.
Yeah, okay. I'm sorry
Yes,
about
sir.
it. There is a lot of server issue here. I think the Wi-Fi is going off and on, off and on. Um, Let me just connect to my mobile, data. So there is, yeah, we can trust the mobile data network than the Wi-Fi for today. So there, I think there is a server issue. I'll again, get disconnected. Don't worry, I'll be back. I'll just connect, to my mobile hotspot. Yes, children, I'm back. So I've switched to a different network. I hope, now there would not be any problem. Fine. So coming back to our question, I'll again, explain the question. The question is you'll have to find out what are the readings of the ammeter and voltmeter. Okay. So you can see that you have two resistors, 24 and 6 connected in parallel. Okay. And two ohm resistor in series. The entire combination of 24 and 6 is in series with 2 ohms. Okay. As you can see from the figure. The entire circuit is connected across a 48-volt cell. This is not a battery. Okay, I suppose you guys know the reason why. All right, you just have it's a single component.
Yes,
Yeah,
sir.
yeah, that's why you call it a cell. You don't call it a battery. The minimum criteria to call it a battery is you have to have a combination of at least two cells. Only then you can call it a battery. All right. Now you can see that there are three ammeters A1, A2, and A3 connected, and you have two voltmeters V1 and V2, wherein V1 is connected across the 2 ohm resistor and V2 is connected across the 6 ohm resistor. And I told you that voltmeters are always connected in parallel, and that's why it's connected across. Okay, but you can see the ammeters are in series. A1 is in series with 2 ohms, A2 is in series with 24 ohms, and A3 is in series with the 6 ohms. Okay, so this is all about the circuit. Okay, you have to find out the readings of A1, A2, and A3. Now, when you have such circuits, when you have complicated circuits like these, the first and foremost thing that you will do is convert this circuit into a single resistor circuit. Okay, make it a single resistor. So that's what is our main objective. So who can tell me, if you convert this into a single resistor circuit, what would its resistance value be? So 24 6 is in parallel. Reduce that. The entire combination would be in series with 2. Add it and tell me the answer. Okay? Anybody? So first you would do 24 parallel with 6, and this entire thing would be in series with 2. So how much does this give you? What value does it give? 24 in parallel with 6. Come on. 24 times 6. R1, R2 upon R1 plus R2, isn't it? So 24 times 6 upon 30, right? Because your R1 plus R2 is 24 plus 6, which is 30. Yeah? So how much does it give? 6 and 30 also you can cancel. Right? So you get 24 upon 5. But it is in series with 2. So you just take the LCM. How much are you getting? 2 5s are 10 plus 24.
34 by 5.
Exactly. So the total resistance of this circuit, which is your effective resistance, is 34 upon 5 ohms. I hope it's clear. Yeah? So effective is 34 by 5 ohms. Let us keep it. You don't convert it to decimals. Still, we are not done. Okay? So that's it. This is the total resistance. Now, when you say total resistance, you can also find out the total current, right? I total or I effective. So how can you find out the current? You have the value of potential anyways. The cell potential is given. So what is the formula for current in terms of resistance and potential difference? I is equal to, just rearrange your Ohm's law formula, you would get it.
I equal to V by R.
Yeah, that's correct. I is equal to V upon R. That is, I total is equal to V upon R effective, the total resistance. V is 48. So I can substitute. So it's 48 upon how much?
48 into 5 by 34.
Yes. After your reciprocal, you can get 48 times 5 upon 34. You go for simplification. Simplify 48 and 34. Okay. Divide it and simplify it. How much do you get? Or you can multiply and then go for a division as you wish. So I think you get 240 if you multiply divided by 34, right?
Yes,
So
sir.
then you go for division. I think it's getting cancelled. How much roughly? I think you get 30 times 5s are no 6. Okay. I think 7 time it goes.
Sir,
7.
7.05.
7 point something. Yeah. So you get 7.0, right? 7.05. Okay. That's correct. 7.05. So your total current in the circuit is 7.05 amperes. Okay. Now, you know that current always flows from positive to negative terminal of your cell or battery, right? So this is your direction of current. Yeah. So this is your I total, which is 7.05 amperes. So that 7.05 amperes is going to go through 2 ohms resistor. And don't you think that is going to flow through A1, right? Same current is only going to flow. I told you in series combination, current is same. But in potential, in parallel combination, current is going to be different. So we have found out A1. So what is A1? Ammeter A1 will read 7.05 amperes. Have you guys understood? That is the reading of A1.
Yes,
So
sir.
once you found out A1, you can also find out V1, right? That is, you have current with you. Can't you find out the potential difference across 2 ohms? So what formula can you use? So what is V1? V is equal to IR, right? So I is nothing but your A1. So V1 is equal to A1 times your R1, that is 2. So how much is that? 7.05 into 2. How much is 7.05 into 2? Multiply 14.1, isn't it? You can directly do it. So 14.1 volt. Okay. So we have found out A1. So A1 was 7.05 amperes. And we have also calculated V1. V is equal to IR. So I total into R. So I'm using the formula now, substituting the value 7.05 into 2, which is 14.1. Is this clear? So V1 is 14.1 volts. Yeah, A1 is
Yes, sir.
7.0. Okay, good. So now you can see that after the current crosses ammeter A1, it is encountering something special. You can see what is this point called? It is encountering a point. I have marked it. I have highlighted here. See, what is this point called? It is called a node, or it is called a junction, right? So what is a node or what is a junction? A node or a junction is again a point, as I told you, where three or more wires meet. You can see that there are three wires meeting at this point, and that's the reason we call it a node or a junction. Okay, so when current enters here, the current is getting split across this node or across this junction. Okay, so you can see incoming current is 7.05, no doubt. 7.05 is entering, but out of that, the currents are getting split. Call this is, say this is I1, say this is I2. So you have to find out what is the values of I1 and I2. Out of 7.05, how much is entering towards 24 in 24 ohms, and how much is entering into 6 ohms? So that you will have to calculate. So how do we do that? Here we are going to use a classic formula which is called your current divider. Okay, so this is very important, pay attention. So whenever you have a parallel combination of two resistors and they have given you the incoming current, they're asking you what are the branch currents or outgoing currents. We have a classic formula for this, and that is called your current divider formula. So I'm going to teach you that current divider. It is very useful for your competitive exams. Okay, so current divider. Okay, so whenever you have two resistors, say the resistor R1 is in parallel to another resistor R2, and you have a node through which you have current I that is entering. Okay, and you have currents that are splitting here. Say this current is I1 and this current is I2. Okay, I is going to split into I1 and I2. So what are the relations between I1 and I2? Can't we write I is equal to I1 plus I2? Yes or no? Because you know that current can't go anywhere, right? It has to be conserved. So whatever is entering has to leave, right? That's the basic logic. So the sum of the branch currents is nothing but your incoming current, which is entering at the node or the junction. So this is one relation. The other relation for current, I mean, this is basically this is not the current divider formula, okay? This is basically your incoming current in terms of outgoing currents, okay? Now, the current divider rule says we can find out I1 provided you know the value of I, that is incoming current. So, your branch currents can be written as incoming current multiplied by the ratio of the resistance, that is where it is entering, where is I1 is going through R1. So I am writing that as R1 upon the sum of the total resistors, which is R1 plus R2 in the circuit. So this is your current divider rule or the current divider formula. Similarly, who can tell me the formula for I2? Again, you will write it in terms of incoming current I into what is the value?
R2 by R1 plus R2.
Exactly, R2 upon R1 plus R2. Simple as that. So this is your current divider rule or the current divider formula. Okay, so same rule we are going to apply for our circuit. By applying current divider, You can find out the values of I1 and I2 in one go or in one shot. So what is the value of I1? Okay, from our circuit. So tell me what is I1. So apply the current divider. I1 is nothing but current which is entering. So the current entering, you need not write it I again because you know it is 7.05. 7.05 times. Here our R1 is 24. So into 24 divided by 24 plus 6, which is 30. So 7.5 into 24 by 30 will give you I1. So how much is that? You just need to multiply and just then divide. Okay. So here you multiply 7.05 into 24. How much are you getting? I think there is a decimal. I think it is 169.2. 169.2 upon 30. Okay. So if you divide it by 30, how much are you getting? You get 5.64, right? So 5.64 amperes. The value of I1 is 5.64 amperes. That means out of 7.05, 5.64 is entering through 24 ohms. So what will be the value of I2? Again, will you apply the current divider? Is it necessary? Will you again apply current divider for I2? Just use the logic. I2 will be 7.05 minus 5.64, isn't it? Just subtract what is entering and what is leaving. You can find out what is I2, right? Subtraction of incoming minus outgoing. So I2 is equal to 7.05 minus 5.64, which is, go for a subtraction. You get 1 point something, isn't it? 1.41. How much is the current turning out to be? Is it 1.41 amperes? You have to calculate it and tell me. Okay, so calculate them. So you get 1.41. So appropriately you can find out. Okay, even by the divider also you will get 1.41 only. Okay, so appropriately you can find out. So using this formula. So like that you can calculate what are the currents, what are the branched currents. Both I1 can be calculated and I2 also can be calculated. All right, so like that you can calculate the corresponding values. Fine. So this is how you can proceed with this. So first step, what we did in this question, we converted this circuit into a single resistor circuit, and then we calculated what is the total current. Once you calculate the total current, we found out what is A1. Now we have found out what is A2 and what is A3. Okay, so that is what we have technically found out. Okay, so that's how you proceed with this question. So we found out A1, A2 and A3. And same way V2 also you can find out. That's not a big deal. You apply the formula for Ohm's law, V is equal to IR. You can calculate the value of V2 as well. All right. So that's how you do it, children. This question. Okay. So I'll give you a question, a proper question. This is just for explaining. I just framed it. Now I'll give you a proper question. Fifth question for the day. So you can try it and you can tell me what is the values. what are the values of the currents for this question. Okay. So here comes the question.
How did it happen? Yen, Yen Archie. Why did it happen? Yen, Yen, what did it happen? Very good, very good. Okay. So I hope you learned this slide. I'm going to next slide. Is it okay? No. Okay. Okay. So next one is this it. Idu. This it. Both are you can say in Tamil idu. That adu.
So 3 ohms, 4 ohms, and 5 ohms, all three are in parallel, and that is in series with 2, and you can see that there is 0.1 ohms also. Okay. So for now, I'll remove the 0.1. It's a very small. That's called internal resistance actually. Okay. So because I have not done internal resistance, we can just remove that. So as of now, we can remove 0.1. You only take this part. So you will have to find out what is the total current flowing in this circuit. So find out the value of I. Okay. First you find out I, and then you can find out what is I1, what is I2, and I3. So who can tell me the answer? First convert it. What is the first step? You will convert it to a single resistor circuit, right? So if you convert it to a single resistor circuit, what is the value of that resistance? That's the question. So 3 is in parallel with 4, is in parallel with 5. And the entire thing is in series with 2. So what is the parallel combination formula for 3, 4, and 5? First find out that. So what's a parallel combination formula? 1 by R effective, you know, no? That formula 1 by Rp or 1 by R effective is equal to 1 by 3 plus 1 by 4 plus 1 upon 5. Simple. So you need to just now find out what is the LCM of 3, 4, and 5. So you can take a common LCM between them. What's the LCM of 3, 4, and 5?
This or it,
60, right? You can take 60, isn't it? So multiply with 60 on both the sides. Simple. So then simplify it. 20, and here how many times? 60 by 4. 15 times, right? And then we go for a rearrangement. So what is RP? 60 upon 20 plus 15 plus 12. Is it 47? Yeah. So you get the parallel combination.
Yes, sir.
The entire thing. So we have found out the value of 3 parallel with 4 parallel with 5 as 60 upon 47. So this value is 60 upon 47 plus 2. Now you go for an LCM. LCM is 47. So 60 plus 47 times 2. How much is that? 94? Now add 60 and 94 divided by 47. That's it. So all this you have to do it as oral calculations. You know, you guys should be good at addition, subtraction, multiplication, and division. The basic arithmetic has to be, you must be thorough, you must be fast at that. So 154, right? Divided by 47. And then you go for a division. So divide it, 154. Rough estimate itself, you get the answer. So you know how many 47s are there in 154? Isn't it? So it is going 3 times. 3
Sir,
point,
3.27.
yeah, 3.27. Okay, so 3.27 ohms. So that is the total resistance. So total resistance in the circuit R effective is 3.27 ohms. So we have found that out. So what will be the total current then? I is equal to V upon R effective, right? V by R. Use that formula. And V was given in the question as 10. So 10 upon 3.27. How much does that turn out to be? Usually 10 by 3 itself is 3.33. So this is 3.27. It has to be less than 3.33. Isn't it? Just click. So you will get 3.0 something. So 3.05, I guess. Right? 3.05 amps. So that is total. So that's your total current in the circuit. So now we have, that is nothing but I, isn't it? So 3.05 is nothing but I. 3.05 amperes. That's it. So we have found out the total current in the circuit. Now you can find out what is I1. You can find what is I2. You can find what is I3 using current divider rule. So who can tell me the expressions for I1, I2 and I3 by using current divider formula? In terms of I itself you tell. So what is I1? I1 is I times R1 upon R1 plus R2 plus R3. Same thing you will apply for each one of them. Okay. The first for I1. Let's write down the expression for I1. Okay. So what is I1 equal to?
This slash 8 is not slash, just symbolic. Slash is
So how can we write I1?
what is here, sir?
In terms of incoming current multiplied by, it is flowing through the first resistor.
Pen is pen, pena. Book is
There are 3 resistors in combination. Okay.
kite is
Simple.
pattam.
So incoming current
House is weed.
is nothing but a total current, which is 3.05
Elephant is yarn. Very good, very good. Okay.
multiplied by, it was a 3 ohm resistor, right? 3 divided by 3 plus 4 plus 5. How much is 3 plus 4 plus 5?
With the picture I have shown you,
12.
so let me read first.
3 ones are 3 fours are. So 3.05 upon 4. How much is 3.05 upon 4? Easily you can calculate.
What is this? You already know
0 point something, right? It should be less. Denominator is more than numerator. So 0.76. Yeah? 0.76 amperes.
okay.
So out of 3.05, 0.76 is passing through I1. Okay? Is the value of I1.
This is step 10.
So we found out I1 as 0.76
Pena.
amperes.
This wool
Done.
pena.
Now what about I2? Same way find out.
This enna.
So I2 is equal to, again, I times, this time it is R2 upon R1 plus R2 plus R3 by current divider rule. So which is 3.05 into R2. Second one was 4 ohms divided by total. Total is, already we have calculated, 12.
Oh, okay.
So 4 ones are 4 threes are. So 3.05 upon 3. It's perfectly 3. So it is going to get cancelled and you will get,
See, whenever you are asking question, no, pena.
what value?
Change to pena. Wow.
1 point, right?
You know, just say pena.
1.01.
So once again I will read it. What is this?
Okay.
Neither
Isn't it? So you get 1.01. So I2 is equal to 1. 3.01 amperes. So what is I3 then? That also you apply current divider. We will verify it again. I know you can use it shortcut method also, but still I insist you to use this so that we can verify. So I3 is equal to I times R3 upon R1 plus R2 plus R3. Okay, which is 3.05. R3 was 5 ohms divided by total is 12 ohms. Okay, so here 5 and 12 you can't cancel. So you can multiply 3.05 with 5 times 5. So 15 point something, right? So that's 15.25 divided by 12. Then you go for a division. How much is that? 1 point,
1.27,
yeah,
sir.
1.27. So it's 1.27 amperes. So I3 is 1.27 amperes. Now, you know that I is equal to I1 plus I2 plus I3 because I is the incoming current, isn't it? So, is it really true? Just add them. 0.76 plus 1.01. If you add this, how much are you getting? One
0.
point 77 plus 1.27. Just add everything. Are you getting 3.04? Yeah, which is very close to 3.05. Yes or no? So technically what we have done is absolutely right. This is how you verify. Okay, so you can see that the incoming current is sum of all the outgoing currents. So this relation holds good. Okay, so this is how you verify your answer. So now we have found out the values of I1, I2 and I3 in this circuit. Is that clear? So this is how you find out the branched currents, provided you know what is the incoming current. So to find incoming, you will have to find out the total current. So total current to find, you will have to first reduce the circuit into a single resistor circuit. So this is how you solve this type of questions. The approach to solve complicated questions, circuit related questions especially, is to always reduce the combination of resistors into a single resistor. Find out the total current because potential difference or voltage will be given, and then you find out the current. Once current is known, use current divider and then find out all the branch line. So this is the approach to solve these type of questions. Okay, so we have found out I1, I2 and I3. Simple. Okay, so this is all about solving questions related to current, the circuits. Whenever you have combination of resistors, different combinations, this is how we are going to solve it. Okay, I hope this part is now clear. So this type of circuit related questions are necessary. That's the reason I have shown it to you. Okay, and now we look at the other different concepts which are there. Okay, so we are done with the combination of resistors successfully. Ohm's law is also done. So now I'm moving on with the next concepts, the forthcoming concepts. Okay, then we have the concept of resistivity. Now we are moving on to the next one. Let's see what is resistivity. Okay, this resistivity is given by the symbol rho. So we'll see how does this rho come into picture, or resistivity comes into picture. For this, we need to understand what are the factors which are going to affect the resistance of a conductor. So factors affecting the resistance of a conductor. So there are different factors that can affect the resistance of a conductor. Among that, the first and foremost is the length L. So as the length of conductors increase, so does the resistance also. Meaning, resistance is directly proportional to the length. You increase the length, resistance will also increase proportionately. That is one.
Uh, the area of cross section, sir.
Yes, correct. Second one is the area of cross section.
Raise your voice like this. Tenava.
Resistance is inversely proportional.
Yeah, you're right. So the resistance is inversely proportional to the area of cross section. Okay. I mean, area of cross section, we will use the symbol A because some books, they use different symbols. We will use NCRT symbol itself. They use A. Okay. So I will use A itself here so that there is no discrepancy. So area of cross section A, it is inversely proportional to A. Okay. So these are the two relations. You can mark them as equations 1 and equation 2. So you're combining 1 and 2. What do you get?
Resistance equals R and A, R by A.
Yeah, the resistance is proportional to L upon A. That's not R, it is L. Okay. So resistance R is proportional to length upon area. This is what you get. Once you remove the proportionality sign, you guys know what you need to be doing, right?
Add a constant.
You add a constant, that's right. So that constant is your resistivity. So therefore, you get the relation R is equal to rho L by A. This term rho that you see is called resistivity. And if somebody asks you, what is the unit of resistivity? What would your answer be? Can we calculate? Can we find out the unit of resistivity? Is it possible? Yes, it is. How? You just need to rearrange. So you rearrange the equation, what do you get? You get rho equals to R A upon L, isn't it? What is the unit of R? It is ohms. What is the unit of A? Area has got the unit square meter or meter square, and the unit of length is meters, right? You just cancel meter square and meter. What are you left with? You're left with ohm meter. So this is how you calculate the unit of, you determine the unit of resistivity. So resistivity has got the unit ohm meter, and we have proved it here by using units and dimensions method. So easily you can find out. Simplify the units and get it. Okay? Simple. So this is all about the concept of resistivity. Okay? So this is how resistivity is calculated. Is derived. So I've just shown you the simple derivation. Okay? Yeah. So with that, now we are moving further to the next concept. Then we have the temperature coefficient of resistivity. So we are going to see how temperature also plays an important role. As temperature increases, so does the resistivity also for a conductor. Okay. So temperature coefficient of resistivity. It is also called as temperature dependence also. Both are one and the same.
Is it different from pronunciation wise like
Okay, so temperature coefficient or temperature dependence of resistivity. So we can express the resistivity at a particular temperature, rho T equals to rho naught times 1 plus alpha delta T. Okay. So what is rho T? Rho T is nothing but the resistivity at temperature T. Okay. Or at final temperature T. Rho naught, what is that? That is resistivity at initial temperature, which is T naught. Okay. And what is alpha? Alpha is your coefficient.
Okay. What is this?
Coefficient of resistivity.
This is a pen. Idu pen.
And delta T,
Change in temperature.
change in temperature. That's correct. All right. So these are the meanings of the individual terms that you see in the equation above. So now we are going to write down the formula for change in temperature. I think you guys know this. change in temperature can be expressed as final temperature minus initial temperature. Final temperature is T, as we have assumed. The initial temperature is T naught. So this is the formula for change in temperature. All right. Like how we have learned, change in velocity is final velocity minus initial velocity. Same logic goes here also. Okay, simple. So this is all about the temperature coefficient of resistivity. Okay. Now please note temperatures are always in Kelvin. Okay, standard unit of temperature I'm talking about. If they are going to be in a smaller unit, in that case it would be in degrees Celsius. So when I talk about standard units, now options would be given. If the options are in Celsius, so appropriately it is in CGS. If it is going to be SI, then it is going to be in Kelvin. Okay, but typically for solving questions okay, so you can keep it in Celsius and then you solve it. It's per day, but if it is going to be in standard or scenario, that Celsius only for most of the questions they use standard the Celsius. Okay, so that is something that you have to keep in mind. This is extra. Okay, so moving on. Next we have conductance and conductivity. So we'll see what is conductance versus conductivity. These are also quite simple terms, not complicated. So we try to understand them. Conductance is nothing but the reciprocal of resistance. Okay, conductance is defined as your reciprocal of resistance. So what is the reciprocal of resistance? Conductance is given by the symbol G and conductivity is given by the symbol sigma. So how can you write G? G can be written as 1 upon R. Okay, and what the unit of resistance is ohms. So what is the unit of conductance then? It is ohm inverse. Okay, so because that comes to the numerator. So ohm inverse is called as Siemens. Simon is the unit. Ohm inverse is nothing but Simon. Or it is also called as Mho. M-H-O. This is basically the reverse of ohm. Okay. So when you reverse read it, you get Mho. M-H-O. So this is the unit of conductance. Now going back to conductivity, you can see conductivity is sigma. This is the reciprocal of resistivity for your information. So let me just write that down.
Actually, I want to share one.
This is reciprocal of resistivity.
If we are not, if anybody is not trying, I'll just share that.
So how can you express it?
1 minute motivational speech.
You can simply say sigma equals 1 upon rho.
Is that okay?
And what was the unit of rho? It was ohm meter, isn't it? So what would be the unit of
Stop sharing this.
conductivity then? So it's going to be ohm inverse, meter inverse. Okay, or it is also called as
Share this video.
Mho meter inverse or Simon meter inverse. Okay,
Actually, it is very difficult. Just 1 minute video.
so it is called either Simon meter inverse. Anyways, that's not important for us. Just know the units. That's enough. Okay. So this is how you can express. This Mho is nothing but your reverse symbol of resistance. Actually, okay, you write it the other way around. You get it. Simple. So these are the terms conductance and conductivity of different conductors. So these are additional quantities that you will have to know. So that's all about this. So again we are moving on to the other concept. Next we have the concept of power. What is power? What do you mean by power, basically? So power is called the rate of doing work, right? Basic definition of power. So what is the rate of doing work means? W upon T, right? W is your work done, T is time. So rate of doing work is power, right? Do you remember the first formula, the second formula that I taught you? Work done in terms of potential difference and charge, right? So how can you write W? Work done. It can be written as Q into V, right? So you can express it as charge into potential difference. But what is Q by T? We know that the rate of flow of charge is nothing but current, right? So we can write it as V into I. So this is the formula for power. So power can be written as V into I. You substitute for Ohm's law for each of the terms. If you substitute for V, you would get I square into R. If you substitute for I separately, you will get V square by R. So these are the different formulas for power. Okay, VI, I square R, V square by R. What is the unit of power? What is the SI unit of power? Power is always measured in watts. Okay, that is the SI unit. Okay, the SI unit of power is watts or watts. Okay, however you call it. So this is all about power. Okay, so this is a simple concept of power. Fine. And next you have something called as Joule's heating. So Joule's law of heating. So you can find out what is heat. So whenever you have an object, okay, an instrument or a device that is connected to a power supply. For example, you can just take your smartphone, you put it on for charging for say an hour or two. Have you observed that it becomes a little hot,
Yes,
right?
sir.
Yeah. So that is nothing but the Joule's heat. So technically speaking, heat can be expressed as the amount of power a device is consuming for a specific time duration. So heat can be written as power into time. Okay, because obviously power is being consumed by a device, right? When you're charging it. So what is the formula for power? Substitute. So power is can be written as V into I. So you can write it as VIT, or you can write it as I square RT, or you can also write it as V square upon R into T. Okay, so it's exactly the formula same as power except for that additional T term which is getting multiplied. Okay, so this is your Joule's heating. You can find out what is the heat dissipated by a device, so using this formula. Okay, so what is the unit of heat? The unit of heat is joules. Okay, shortly we write it as J. Okay, so this is all about joules heating. Simple. Same way, we'll finish the concepts for today so that you can learn all of them. Then we have electric power. Electric power, I just told, electric energy, let us say. Okay, electric energy consumed.
Yeah, thank you, madam.
Okay.
Yeah.
So you can write down
Because
energy
think,
as E is equal to.
We'll do even between the.
So when I say energy, you know that energy has got the unit
Between the weeks also we'll do.
joules. Okay.
Yeah,
Your electric energy. Fine.
Thank you. Thank you, Sandeep.
So very similar to your
Niveen
heat.
or
So
Nilesh
energy
or
can
all
also be
those
expressed
people,
as power into time. Keep it in mind. Okay. So we can also express energy as the amount of power consumed for a specific time duration. So that's how you can express it. Simple. So now when I say electric energy, now you can see that in our homes we have an electric meter, right? An electricity meter is there. Why do you think we have a meter? We can just consume how much of our electricity we want, right? That's not possible because we'll have to pay for it. It is a service. So therefore it is a utility. So when you consume, based on the amount of consumption, electricity bill would be generated, right? And you will have to pay the bill. So how, in what units is that measured? Has anybody observed the electricity in joule?
Kilowatts.
Yeah, it is measured in kilowatts. The amount of kilowatts you're consuming every hour, so that much bill you will have to pay. So that depends from state to state, right? So each and every 1 kilowatt hour we call it, okay, kilowatt hours. So the power is technically measured in commercial units as kilowatts, and time is in hours. So combining both, it is called kilowatt hour. So kilowatt hour is the commercial unit of electricity. So based on how many kilowatts you're using every hour, you will have to pay the electricity bill. Now, this is the unit. So let's try to now substitute. So when I say kilowatts, so we try to understand what is 1 kilowatt hour. We'll try to convert that in terms of joule. So kilo is technically 1000, which is 10 power 3 watt hours. Now 1 hour has got how many seconds?
3,600.
Exactly. So 3600 into 10 to the power 3. So now you can convert it in terms of joules. Okay. In standard units, you can write it as 3.6 into 10 to the power 3 plus 2 plus 1, which is 6. So 1 kilowatt hour is technically equal to 3.6 into 10 power 6 joules. This is the conversion. This is how you can convert from kilowatt hours to joules. Okay. So this is all about your commercial unit of energy and its conversion to joules. So whenever commercial units are given in the question and they're asking you what is the amount of energy, in that case, you will have to convert it into joules and then express the answer. Fine. So this is all about the kilowatt hour or the commercial unit of energy. All right. So this is one. And I think you guys should be knowing what is meant by a fuse.
Yes, sir.
What is a fuse?
It's a material that is used to cut off electricity, which is, it has a very low melting point, so that when excess
Okay.
electricity passes through it, it melts and saves the other elements connected to it.
Yes. So typically, a fuse is a device that, cuts off the supply of electricity when, more current is going to flow through it. Because now we have a lot of appliances in our home. Like we have television, you have washing machine, you have your geyser, etc., etc. Now, what it can happen so during monsoons or thunderstorms, okay, there can be a huge surge of current. Okay. So therefore, this is a protection equipment or a protection device which can protect, your appliances when a sudden surge of current is going to enter inside your circuit. You don't want that to happen, right? So your appliances would just go boom. You don't want that to happen. You will have to invest a lot of money. So therefore, this is a safeguarding device which can safeguard your appliances from huge surge currents, especially when there are voltage fluctuations. You can see that sometimes voltage can fluctuate due to different reasons. Okay, yeah, I don't know if you guys have observed. Suddenly lights go dim or they become dark, they become bright. Okay, it can happen. So therefore, you have something called as voltage stabilizers also. Earlier, people were using voltage stabilizers. Why? Why don't we buy voltage stabilizers and use it for, one for fridge and one for television, one for your washing machine? We don't do that nowadays. Things have changed. Why? What is the change? Can anybody explain? Why aren't we using it? Yeah? Is it
Because
because yeah, tell me.
they have an inbuilt one, sir, now.
Yes, you have an inbuilt one, exactly. The televisions manufacturers have come up with a smart solution. They have inbuilt stabilizing units that are present. That is called an SMPS. SMPS unit is present. It is a smart voltage stabilizing unit that is present inside. Okay, you don't need to, you don't require an external voltage stabilization. Your washing machines have them. Your television sets have them. Okay, so all appliances that we are using in day-to-day life, including your laptop. When your laptop is put for charger, I hope you guys have seen that huge cuboidal, box like thing. So that is nothing but your, again, voltage stabilizing unit which is present. It's like an adapter. So that is got. Even your mobile phone adapters have it. Have you seen the huge plug? Right? The plug. Why is that plug so big? That's because there is an adaptation setup inside, and there is also voltage stabilization that is taking place. Okay, so all this is there. But fuse was used in earlier days. Nowadays, we don't have a fuse in our circuit.
We have an
Okay.
MCB.
Exactly. We have an MCB or an ELCB. MCB is the abbreviation for miniature circuit breaker. It can break the circuit during events of, short circuiting or during overloading. Suppose you are connecting a device that requires more current into a socket that can only supply less current. What is happening? You are basically overloading. That means you are trying to consume more than it is meant for. Your demand is more, but your supply is less. That means you're overloading the circuit. That is one example. One more. Have you seen if you are going? People are trying to take connecting, a particular socket to an extension box. Extension box has so many sockets in it, and everybody goes and connects there. One person is using a laptop. One person is connecting a fridge to the same thing, and one person is connecting a microwave oven. So what do you think is going to happen in this case? From a single socket, you are trying to power three devices, out of which two are consuming a lot of power, right? That is your refrigerator and microwave oven. You cannot do that. Now what happens when you do that? You are trying to overload. So that is called overloading. Okay, where you're trying to consume more power than the required output. Okay, so what can happen during overloading? The wires get heated up so much, and the insulation coating would get disrupted. The live and neutral wire can come into direct contact, which is also going to lead to short circuiting. Okay, there can also be a potential fire. So therefore, to avoid all this, we have a safety device called an MCB. The moment NCB detects a huge surge in current, a slight variation, it would immediately trip. TRIP. What is called tripping? It goes off. So you will have to manually switch it on. Okay. So that is the job of an MCB. And the response time is also very quick. Within micro or milliseconds, it trips. It's very fast and it can safeguard your appliances. All right. So this is all about the recent day smart systems that we are using. It can be MCB or it can be an ELCB. We also have an auto shutting unit which can auto shut down the power. That is also available. That is just going to have a sensor. That's it. The sensor will sense and it will just switch it off. Okay. And the once the circuit is right, once you have disconnected the overloading part, you have identified where the defect is, it will automatically switch on. You need not go and manually switch on like you do it for an MCB. Okay. So that is automation. So that's how things work real time. Okay, so I have shared in more information for today. So we have learned about fuse. I have also taught what is short circuiting, what is overloading. What do you mean by earthing? Have you seen the earth wires?
Yes, sir.
Yeah, they are coded, they are having a specific color. Have you observed?
It's, I think it's green.
Exactly, it is green. That's correct. Okay, it is green in color. So if you can see now modern day circuits, we have separate colors for wiring. So which enables electricians to identify what each and every wire means. Okay, there is a live wire, there is a neutral wire, there is a earth wire. Okay, so the earth wire is used for what purpose?
I think to send away the excess current, sir.
Yeah, it is to safely reroute excess current, especially when you're working with huge machinery made up of metallic finish, that's having a metallic finish. Okay, so that you don't get a shock. Fine. So it prevents you. So that's the reason you have earth wires, and you wherein the 3-pin sockets are there. Okay, so all 3-pin sockets have an earth wire. It can be your air conditioner, your refrigerator, microwave oven, induction cookers, etc., etc. The ones which have a higher power consumption. Okay, yeah, when you're handling them, to prevent the risk of electric shock, the earth wire is there. That's also a safety methodology. All right. Yeah. Fine. So I think we are done. We have exceeded the time limit. Even I didn't know, the time just flies away like that. Okay. So it was nice to converse and know a lot of information.
Manish,
Right?
just one information I wanted to add. You said
Yeah.
SMPS, I think the full form is switched mode power supply. Am I correct?
Switched mode. Yeah.
Ah,
Switched mode power
power
supply.
supply. Okay.
Yeah.
So my all these electronics now coming out from my brain.
Yes.
So good. Thank you,
So
Manish.
yeah. 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 Sure.
Children, lot of I think valuable information you gave. So it's nice. Somebody is knowledgeable in physics as well as some practical aspects of engineering or current. So I think we are proud to have Manish with us because of these reasons. Okay. So all of you, any doubts you have, you bombard him with doubts. That is what I want. But children are very hesitant, or they don't get time to even ask questions. Normally, I thought children will not have time to answer the questions, but now they don't have time even to ask questions.
Ask questions.
The 12th standard, 11th standard is so tightly packed in your timing, all schools.
Yeah. Yeah. Yeah.
So this is a problem of the education system, but I think you have to thrive on this education system. You feel free to ask any questions to any of our teachers, and raise the question. Even if they are not able to answer in the school, in the class, they may be able to answer over our group, and sort of, because frankly speaking, the entire igniting young mind, we have plenty of engineers, not one or two. I have at least 50 engineers with me to answer any questions on physics or chemistry or mathematics. Maybe biology, I may not have that many people, but engineering, we have
Correct.
plenty. Okay, thank you. Thank you, children.
Thank you, sir.
Yeah, thank you, Santosh. Yeah.